Hello, my name is Clement Lim Jun Long, and today I'll be presenting about my simple recipe finder for Software Fundamentals VIT 1244. So let's look at the problem statement. The problem statement, finding recipes with ingredients manually. This is way too slow. So to overcome this problem, we develop a solution that is to create a simple recipe finder to quickly find the desired recipe. So let's look at the system input. On the left here, there's a diagram that shows about what the program will show. First, it welcomes the user, and then it will show the ingredient, and then it will show the ingredient list, such as, and then it will show, and then it will ask the user to enter their ingredient at the bottom here. So the system input first, the system receives the input from the user through the use of the scanner function, and then when the program is running, it will ask the user to enter the ingredient as denoted by the enter your ingredient here. Sorry, just zoom in. As noted by this one. So next, sorry. So that's it for the system input. Next, for the system output, on the diagram here, it shows the user enters. So in the diagram on the left, the user enters parsley, which returns the recipe bologna spaghetti. This is because the system will display the matching ingredients after searching its recipe record. So yeah, as shown by this step here. And continuing for the system output, there are more examples here. On here, the user enters cucumber, and then the simple recipe finder will return the recipe nasi lemak. For the center here, the user enters the ingredient dough. The system will return a recipe, the recipe cheese pizza. And then in this example, the user enters the ingredient, the whole chicken, and then the simple recipe finder will return the recipe roasted chicken. So let's look at the program limitations. First, the program is unable to directly search for the recipes, as it can only search for recipes using the ingredients provided by the user. This means that the user cannot directly search for the recipe itself. It must search for the recipe through entering the ingredients only. So they cannot just jump from the recipes directly. They must go through the ingredients. Secondly, the program does not have a search function that can sort recipes by another function, such as preparation time, calories, and serving size. That is for the program limitations. So let's look at the flow chart briefly. Here, the program starts, and then it welcomes the user and displays the ingredient list. Then, on the next step, the user enters the ingredient. After the user enters the ingredient, the program searches its own entry for any recipes matches, and then it will come to this decision box here. Has the program found matches? If yes, it will display the matching recipes, and then the program will end. However, if the program did not find any matches, no, it will prompt the user to enter a different ingredient, and then it will loop back, and then it will come back to the user enters ingredient. So the user will need to enter a different ingredient. That's it for the flowchart. So let's look at the pseudocode. This is the pseudocode. We're just going to go through it very briefly. The program starts, initializes, a scanner is created to record the user's input. The recipe list array list is created, and then here we place all these recipes into the recipe list. And then we will display the welcome message and ingredients list. The program will print out into your ingredient, and then we will set the user input into the variable ingredient input, and then convert the string to lowercase to avoid any search errors. So by default, we will set the match file to false. So this is the default state of match file, false. And then and then it continues on the right here. For every recipe in the recipe list, if ingredient input is present within the recipe, it will display the recipe name, and then it will set the match file to true. Earlier it is set to false, and then the program will it will end if and for, and then here if the match file still happens to be false, then the simple recipe finder will display no recipes found. Please enter one ingredient only or a different ingredient, and then the program will end. That's it for the pseudocode. Let's look at the looping structure. This is a piece of the looping structure used within my program. Here I use the for loop, which is used for the simple recipe finder program. The justification, the amount of iteration is known, and it provides a reduced risk of infinite looping. As for the data structure, here is the array list, a piece of the array list in my program. Array list is used here to store the recipes in the system's record. Justifications, it supports dynamic sizing, and it provides fast access to the elements. Test case table. Here we have the valid input for the test case table. So we're just going to look at this one. Test case ID TC01 to identify, and then the test description, we put in a valid ingredient. For the input value, we put in whole chicken, and then we expect the output to be recipe roasted chicken and actual output to be the same as the expected output. So this means that this is pass. This passes the test case. For this one, it's also the same. It's just a different ingredient. So let's look at the invalid input for within the test case table. Here, test description, invalid ingredient. Let's say I put in Sichuan sauce. The expected output, no recipes found. Please enter one ingredient only or a different ingredient. This is because Sichuan sauce is not used in any recipes within any recipes within the record. So the actual output is also no recipes found. Please enter one ingredient only or a different ingredient. And then this will pass. And then for the TC24, it's also the same case. It's just a different ingredient. Let's look at the behavior table. So this is the behavior table. Let's say if I put in ginseng root, expected output, no, it will provide the error message. Actual output also the error message. The program correctly rejected an invalid ingredient and given by the user. However, let's say if it's a correct ingredient, a valid ingredient, let's say it's parsley, expected output bolognese spaghetti, and the same for the actual output. The program correctly accepted a valid ingredient given by the user. The difference here is the validity and the invalidity of these ingredients. So let's look at the correctness evaluation table. So let's look at the invalid input, the helium mushroom. This is an invalid input. So the expected output is the error message, and the actual output is also an error message. So this means the result is a pass. Let's say if I put in a valid ingredient, your expected output, it will return a recipe, bolognese spaghetti, and the actual output is also bolognese spaghetti. So this is a pass also. And well, if you put in an integer, it's also an error. And if you leave it blank, it will also be an error. So these two are also pass. So accuracy of programming logic table. Here we have items and evaluation. Input string check. It is correctly implemented. For the evaluation of this, it is correctly implemented using if recipe enter dot ingredients dot contains ingredient input. On the second one, data type check. It used scanner to receive the correct input information from the user. For this one, error messages. The error messages are clear and appropriate for every type of accepted input. As for edge cases, whole chicken and parsley, this is because the whole chicken is the first ingredient and the parsley is the last ingredient. The evaluation for this, properly accepted. Outside limits, let's say Sichuan sauce, helium mushroom, as we saw earlier, they are properly rejected. And that's it for the accuracy of program logic table. So let's look at the functional table. Functional requirement, accept user input for the ingredient. This is met because it uses scanner to receive the inputs from the user. Functional requirement number 2, ingredients only within the accept ingredients only within the ingredients list. Met? Yes, because the system uses if statements to validate the user's input. Next, functional requirement number 3, provide the matching recipes after the input is correct. This is met also because the system will display the corresponding recipes that match the user's entered ingredient. And lastly, for the functional requirement table, it rejects any ingredient not included within the ingredients list. This is met because the system will provide an error message and ask the user to enter a different ingredient. So let's look at the non-functional table. The non-functional requirement, first one, maintainability. This is met because methods are utilized within the Java program code, which facilitates the program code to be more modular. Secondly, usability. This is met because the user is provided a clear and obvious prompt for what to do with alongside the relevant informations. Error prompts are used as well to indicate a problem. And here we have responsiveness. The system reacts quickly to the user given input. There is no delay or lag in between the user interaction and the system. And robustness. This is met because the system can handle user input text and blank inputs without crashing. So let's look at the live demonstration. For this one, I'll use a program with online Java compiler. Just give me a moment for it to load. Here, I will copy the code from my report into the list. Okay, pseudocode slot. This is the pseudocode code implementation. Okay. God, okay. Okay, and then just show. Oh my goodness. Okay, sorry about this. Okay. Okay, here we have the code in the program list, and this is the output. So it welcomes the user. It welcomes the user and provides the ingredients list. And then it will ask the user to provide their ingredient. Let's say I put in parsley. It will return the recipe bolognese spaghetti. And let's say if I want to search for a different recipe with using this software. Let's say I use eggs, and then it will return recipe nasi lemak. So that's how the program works. And let's return to slides. And that's it for the presentation. Thank you very much.